So you can see that we have already stated and completed measure of the topics related to the basics of groundwater. Now today we'll study more in detail about the various groundwater features. Now I'll be briefing you about the various types of groundwaters, its properties, and how does their effectiveness depends on what are the specific rock types, how does it behaves in different rock types we'll be studying today. So we already know that hydrospheres includes water in and on Earth's surface. 97% contained in ocean. 90% of the fresh water is in the form of polar ice caps and glaciers. Ultimate source of all water on the land is oceans, and this entire operation depends on infiltration, where the water enters the ground and becomes groundwater. So you can see through the diagram how you have got a precipitation and how those precipitation water will be saved in the ground, and thereafter it will be infiltrated downwards, and finally it will be stored as a groundwater. So what do you mean by groundwater? Groundwater is the underground water that fill almost all pores in the rocks and sediments. So generally what we are using this underground water for our drinking purposes. Generally we have got rainfall for only 4 months, and this 4 months of rainfall is being stored in the form of underground water, and that is used for rest of the season. So how that groundwater is recharged? It is recharged through all these pores in the rocks and the sediments. So what is pores? Pores are the open spaces between the fragments of weather rock and sediment. So we have already studied about porosity and permeability. So we are familiar with the movement of the groundwater. So I'm not going much into the details. And it supplies about 1/5 of the fresh water needs, where the groundwater system is equals to the area that has connecting pores. So there are various forms or zones that has to be studied whenever you're studying about underground water table. So what are the different kinds of zone? One is zone of saturation. So here you can see in the diagram what is the zone of saturation. Here you can see that the zone of saturation is fully filled with water, and zone of aeration there is a possibility of infiltration. So what is that? So zone of saturation is the layer of ground where all the pores are filled with water. So you can see that all the pore spaces are filled with water, and whenever such condition happens, or you will see in the ground underground, that is known as zone of saturation, where all the layers or pores below the ground surface are filled with water. So how does it happen? It happens through two processes. One is gravitational water, where the water that trickles down due to gravity. So that is natural. Whenever you will see because of the gravity, there will be downwards movement of the water. And the other one is because of the capillary rise of the water. So water is drawn upwards from the water table. So now there you can see there is a water table written. So what is the water table denotes and how you can define it? So water table is the upper surface of zone of saturation. So in a single word or in a single definition, you can define water table as the upper zone surface of the zone of saturation. And what are the condition on which this underground water table depends on? It depends on the various depths depending upon the local condition. Then topography will follow. Topography of land above it, whether it is a vegetated land or whether it is a unvegetated land. So all such topography will depend on the land surface. The third characteristics depends on the precipitation. So it will vary with seasonal and other weather condition. So as you are seeing that in many parts of the country, you are facing flood in many parts of the country, or in some parts of the country, you can feel like there is no rainfall, there is a drought like condition. So it all depends on the precipitation, and on the depending on the precipitation, your water table will vary. So you will see that in the desertic terrain the water table is quite low, and when it comes to the plain surface, when you compare yourself with the water table of UP, Bihar with Rajasthan, you will be finding Rajasthan with a lower water table when you compare with the plain areas, and that is because of the precipitation, topography, soil, land use, then structures, soil type. So all depends on such features. Then you have got rise during wet seasons, drops during dry season. So what you will have, this water table, if you compare when we go for the research, uh, we use water table of different seasons. Generally, we classify the water table into two different season. One is pre monsoon, one is post monsoon. So when you will compare the pre monsoon water table with the post monsoon water table, you'll find that the in the post monsoon table the water table is very high, and when you compare that with the dry season the water table is low, and that is because of the precipitation. So all the water storage, the underground, the surface water, underground water, all depend on your precipitation, all depends on your runoff. Then other option was, or the other layer above zone of saturation is zone of aeration. You can see this zone of aeration. So what does zone of aeration means? It lies between the water table and the earth surface. Means on the top surface and below the ground of zone of saturation there is a surface that is denoted by zone of aeration, and it depends on uppermost region that is equivalent to hold soil water forms fill around the grains of topsoil. Here, the entire layer is not fully saturated with water, is not fully consumed with water. There is a possibility of infiltration. That's why you have got two different regions. One is uppermost region where the water is held by the soil, by the topsoil, by the ground grains, and in the middle regions generally it will remains dry except during the rainfall or mostly through years. So zone of aeration consists of water particles, consist of uh, air. So, and the third one is capillary finch, that is the bottom region where the water drums up from the zone of saturation, and that attracts the water molecules to the other material. So you can see this, how the movement of water take place from the saturated zone using capillary finch to the unsaturated zone, and finally you will be finding this infiltration happening through this zone of aeration, passing through it, and finally it will be going into the zone of saturation where the entire area will be filled with water. So what are the different rock properties that affect the movement and storage? The first one is flows downhill in the direction of slope of water table due to gravity. I've already stated that if you see right now the flooding condition in Himachal, if you compare that with the flooded condition with Bihar or UP, you'll find that there is a difference in the velocity of the river. The difference in the velocity of the river is whenever you'll see the pictures of the flood-like situations. Recently in Manali, you had a landslide, and then you have got flooding in Chamba and various Jammu and Kashmir. That was very dangerous, and that is all because that you have got a high topography in the mountainous terrain if you compare that with a low topography in the plain area. So there the water literally expands, but here it flows because of a high drainage density. It flows with a greater volume, and that's why the rate is too high. So the rate depends on the permeability of the water and the gradient of water table. So you can see that what are the different kinds of grain size or the different kinds of soil available in that area, and what is the slope in that area, and depending on that the velocity differs. So flow velocity through permeable material is always higher than those than unpermeable material. So obviously we have done with the porosity, permeability we have done. So when a surface is permeable and when the surface is impermeable, what will happen? So in a permeable surface, always you will be finding that the velocity will be very high when you compare that with a impervious surface. Then the second one is porosity. Porosity is a percentage of open spaces in a given volume of rock or sediment. So that is the void spaces that is available in any rock types or soil types. So it is determines the amount of water a rock can hold. So the property on which a rock can hold the different kinds of water is known as porosity, and that depends on the cracks, fractures, joints, lineaments. Such properties or such structures are having the potentiality of carrying this water to the underground surface. And finally, it is influenced by sorting, means the amount of uniformity in the size of the particle in sediment on rock. Like if you have got different shape, size of the particle, we have already studied how the different kinds of porosity and permeability will differ on different particle size. A well sorted has particles all about the same sizes. Purely sorticles has particles with various mixed types. So depending on the particle size, your runoff will vary. Then the way particles are packed together, if it is packed loosely, then it has more open spaces with a high porosity. When it is tightly packed, you have got few open spaces with low porosity. Then you have got permeability. Permeability means how freely water passes through open spaces in rock or sediments. It is affected by size, sorting of particles that make up a rock or sediment. Most permeable rocks are those made of coarse particles. So example like sandstone. So you have got an impermeable surface that suggests rocks or sediments through which the water cannot move. So whenever you say that there is a pervious surface, there is an impervious surface. So impervious means where there is no movement of water. Pervious surface means where there is a movement of water. So you cannot you can see how the different rock types are having the different kinds of porosity and permeability. Then the other important terms connected with groundwater movement is aquifer. So what is an aquifer? Aquifer is the layer of permeable rocks that has connected pores and transmits water freely. So whenever you are seeing any wells, that is indicative of an aquifer. So large amount of water can flow through it in the aquifers, and it contains porous layers of sediment such as sand, gravel, and sandstone and limestone. That is the most important feature that is required for conservation of water resources. The other term associated with aquifer, the different types of aquifer you have got. So you have got confined aquifer, you have got unconfined aquifer. So what does aquicludes means? Aquicludes means impervious level that's provide a barrier to the groundwater flow. So this is how the aquiclude look like. If you have got an impervious surface below a pervious surface, such kind of feature when you will find on the ground, that is classified as aquiclude. Then what are the different kinds of topography and water table associated and how they are interrelated? You'll be finding that the water table is found at different depth at different ground surface. Like if the ground surface has got sand material or loamy surface, or you have got clay surface, the water table will depend on different surfaces, and the depth of the water table depends on the topography of the land, means what is the gradient, then permeability, how it is connected towards each other, and finally the amount of precipitation or the amount of rainfall that is belonging to that area. So if you have got prolonged rainfall, water table rises up. So generally what you see nowadays that you have got a high rainfall in particular days, and that generates heavy rainfall, and that's why you are seeing that urban flooding in Maharashtra or in different Bangalore or different parts of the country is more recurrent. That's because of high rainfall, and that is beyond the carrying capacity of a river, and that saturates the top surfaces of the soil, and that creates a flood-like condition in that area. And the drought periods depend on the water table drops and flattens. Means if the water table goes downwards, means you're not receiving heavy amount of rainfall or the water that can go and recharge the underground water table, and that is indicative of drought-like condition in that area. Then you have got post water table. They are the different kinds of water table. That is also known as secondary water table, formed by a layer of impermeable rock above the main water table. So you can see that how this post water table is stored above the water table. So how it is formed? It is formed by when a rock layer prevents the water from seeping down into the zone of saturation. So there you can see this is the water table, means this is a aquifer that is indicative of zone of saturation. But in between this zone of saturation and in zone of aeration, you will be finding some water stored, and that is known as post water table. And that is because that the rock where the water is being recharged doesn't allow to move downwards, where the water collects on the top, creating a second water table. So this is at the basement, you can say this is water table 1, and this is on the top in the zone of aeration. You can see that there is other water table that is known as post water table. And most of the areas only have one water table. Either it will be having zone of saturation, that is a water table, or you will have a post water table. Then erosion and deposition. So usually you will see that slightly acidic and will attack and dissolve the carbonate rocks such as limestone. So you will be finding caves in many of the rock types. And how are those caves constructed? That are constructed naturally by underground opening with connection to the earth surface. Then you will be finding the caverns. They are large cave, often containing many smaller connecting chamber, and that is because of the chemical weathering that enlarges a number of connected cracks and cavities, and commonly in the areas of extensive limestone where the water is slightly acidic in nature. So you will be finding such kind of caves or crevasses created in the various parts of the country. Then you will be also finding sinkholes. You can see these are the indicative or picture indicating the diagram indicating how the sinkhole looks like. So what are these sinkholes? Sinkholes are circular depression caused when the roof of the caverns collapses. Means there is a subsidence. You can also say that is also indicative of subsidence. Means there is a collapse of the land. So you can have a land subsidence that is very common in many parts of Jharkhand, and that can extend below the water table and usually occur during the dry periods. Then you have got karst topography, that is the region where it affects of chemical weathering due to the groundwater, and may include closely spaced sinkholes and the streams that disappear. It generally appears or happens in arid zone and sinking streams, surface streams that drains the cave stream. Then you have got hard water and soft water. Many time you'll see that when you're going to Rajasthan, you'll be seeing the water is very hard. When you go to Himachal, you say the water is very soft. So how does it is indicative of? So hard water contains relatively large amount of dissolved minerals, usually ions of calcium, magnesium, and irons. They are common in limestone areas, and that is unacceptable for many common uses like soap will not produce suds, has metallic taste, household appliances or fixtures have built up of material. So that is very common in Rajasthan. So we are facing or we are using this hard water. But when you go to plain terrain, like you go to UP or Bihar, or you go to Himachal, you will be finding the soft water that contains few dissolved minerals. Then you have got speleothems that are all mineral deposits formed in the caves by the action of water. Then you have got stalactites, that is a cone-shaped calcite deposit suspended from ceiling of a cavern. Then you have got stalagmites, that is cone-shaped calcite deposit builds up from the cavern floor. Then you have column, formed when a stalactite and stalagmite grow together. They are referred to as a drip stone formation because they are formed from dripping water, and it's incomplete. Then you have got veins. Veins are areas of igneous rock where the hot water collects metallic air in solution and then deposits in the metallic ores. Then you have got natural bridges, that is an arc of rock, that is uncollapsed rock between the pairs of sinkholes, and can form when surface water enters a crack into rock formation, runs underground, and then re-emerges. Then you have got different groundwater systems, that is springs. So you have got ordinary springs that are natural flow of groundwater to the earth surface, that are very common in many parts of the country, that are commonly found in the rugged terrains and the hillsides. You'll be finding many of the hot springs that are also of religious importance in many parts of the country, especially in Himachal. Then you will be finding that into Jammu Kashmir, or always some parts of Jharkhand, Madhya Pradesh. So they are very commonly found in various terrains. The where the groundwater surface drops below the water table usually do not flow continuously. It emerges on the sides of the valley, edges of a post water table, or along a fault. Those that form where there is a post water table may flow continuously. So, depending on their occurrence, depending on their location, the movement of the groundwater will depend on. So, in the areas where an aquifer and an aquifluid come into contact, that is also indicative of springs. Then you have got karst springs, that is the area where the entire river emerges from the ground surface. Then you have got different kinds of artesian springs, that is indicative of natural flow of water to the earth surface from artesian formation, where it forms when the cracks naturally occurring in the cap rock, water under the pressure flows to the surface, that is also known as fissure springs. Then you have got hot springs, hot groundwater that rises to the surface below the cooling, where the water heated when it comes into the contact with the magma or passes through the areas where there has a recent volcanic activity. The temperature must be at least 37 degrees Celsius and contains large concentration of minerals. So that is already I have indicated it. Then you have got geysers where the water is coming out as a hot springs that erupt periodically, that shoot up water and steam. That is natural or narrow vent leads to the surface and connects with one or more underground channels. And thirdly, it's eruption that is connected to geysers where it's from surface pool shooting sheets of water and steam, and from small surface vents sending natural columns of water and steam high into the air. Then you have geyserites, that is deposits of silicate minerals that forms different kinds of minerals. Then you have got travertine, that is a form of calcite that is deposited in the traces around the mouth of the hot spring, usually white but turns into gray as it weathers, can be red, brown, or yellow in color. Then you have got mud pots. Mud pots are weathered rock around the hot spring that mixes with hot water to form liquid clay, and that forms bubbles at the surface. Rocks surrounding the hot springs is chemically weathered by volcanic gases and also called as spent ponds. That is, clay can be colored by minerals and organic materials. Then you have got wells. Then what is ordinary wells? Ordinary wells is a hole dug below the water table. Most go down into the zone of saturation below the water table, but if not deep enough, it will dry up when the water drops below the water table. So that is the biggest problem in majority of the wells in India, that during the dry season, the entire wells gets dry up. That is because of this reason. So pumps brings it to the surface. That's why pumping sets are required many times to pump it to the surface. Just like we have got a pumping set or a pump at placed or installed at our home to extract the underground water table. So you have got cone of depression where the load area of water table is produced by pumping water from the wells, then can drop to the bottom of well causing it to dry, and could also cause surrounding wells in the area to go drown. So there is a drawdown, that is the difference between the original water table level and the water level in the pumped well. Then you have got recharge. The recharge is the water from the precipitation and runoff is added to the zone of saturation. So what we are focusing, why we are studying this paper, because we want to conserve this runoff. If you are conserving it, if you are conserving through reservoir, through ponds, tanks, lakes, you can enhance the water table of that area. If you will enhance the water table of that area, you will have sufficient water during the dry season, so your wells won't be drying up during the dry period, and you will have a sufficient amount of water for your daily activities. Then you have got artesian wells, where the holes dug through the cap rocks of Artisan Formation, which is the water that flows freely. For this artesian well, no pumping is required. Artesian formation is because of the sloping layers of permeable rock sandwiched between two aquifluids and exposed at the surface. That's why you have got a cap rock that forms the top layer of impermeable rock. Then you have got aquifer, that is indicative of permeable rock layer, where the waters in the lower part is under pressure from the weight of the water above. Then what are the threats to the water supply? Then you have got threats is overuse. Generally, we are overusing because of high population pressure. We are not protecting the our reservoirs. That is indicative of overuse of our underground water, that the supplies can be depleted is water is pumped out at a greater rate than the recharge. Whenever you are getting more of extraction than recharge, the supply will decrease and water level will drop, and at many places you will be finding subsidence, that is sinking of land due to excessive withdrawal of water. That is very common in many parts of the country. Also, you will find a significant problem of pollution. So most easily polluted are water table, unconfined aquifers. If the recharge area of confined aquifers become polluted, these aquifers will also be polluted because of the industries, because of the waste, solid waste or industrial waste, what, or it can be agricultural waste that we are, the most common are sewage, industrial waste, landfills, and agricultural chemicals. So chemicals are dissolved and transported as ions, and they cannot be filtered out from the sediments. And the coastal areas, contamination of the water is by salt water. So because of the coastal nature, saline nature, the entire water table can get saline. And if the water drops below the sea level, this allows the salt water to enter into the underground water table, and that cannot be used for drinking purposes, and that is a very common problem nowadays in many parts of the coastal areas. And natural pollution, surface is radioactive radiant gases. And finally, we must protect all the major pollution sources need to be identified and eliminated. That has to be filtered and then has to be transported. Then the pollution plumes already in the ground can be monitored by time to find alternative water supply, stop by building impervious underground barriers, Then polluted underground or groundwater can be pumped to the surface for chemical treatment, and we can conserve by various kinds of regulative use, monitoring the levels of local water table, and finally we can discourage the excessive pumping when the water table is low. Getting it, Dipanshu? So now we'll be reading. Can you see the slides? So as I've already stated that aquifer will be going more into detail. What is an aquifer? And aquifer is known as a water-bearing geological formation. That is such formation that transmits the water to the well, springs and rivers. And there are four types of water storing geological formation. That is aquifer, aquifers, aquiclude, and aquitard. So whenever you're talking about an aquifer, it is a permeable geological formation that stores and transmits water. An aquifer is a rock formation containing no interconnected openings and therefore neither transmit nor stores water. That is massive granites. Then you have got aquiclude, that is the formation of rocks which can store water and cannot transmit water, that is clay and shale. And aquitard is an impervious and semi-confined geological formation that transmits water very slowly, that is shale or clay lenses interbedded with sand. So depending on the different composition of the materials or the sand, you will be finding different kinds of aquifers. So the most geological strata are classified either as aquifer or aquifer. Very few formation fits to the classification definitions of aquicard. The ability of the water to store in the rock pores is depending on the porosity. Porosity of the rock formation may be derived from the interangular spaces or from fractures. So you can see how you have got primary openings, then you have got the fractures and the cracks that are used as the secondary opening. So depending on the pores and the fractures, aquifers are described into the following subsection, that is alluvial deposits, limestone, volcanic rocks, sandstone, igneous and metamorphic rock. So we'll be now seeing how it differs on different rock types. When you compare that with alluvial deposits, probably 90% of the developed aquifer consists of unconsolidated rocks. This consists of alluvial sediments of river basin, coastal benching, and deltaic tracts. These aquifers may be divided into four categories based on the manner of occurrence. They are watercourse, abundant, buried valleys, panels, plains, and intermounted valleys. So depending on the different geomorphological formation, you will be getting different kinds of rock types. Then you have got watercourse, consist of alluvium that forms and underlines stream channels and forming adjacent plains. So well located in highly permeable strata bordering streams produces large quantity of water as infiltration from the streams adds the groundwater supplies. Then you have got abundant or buried valleys that are abundant and valleys are no longer occupied by rivers that forms them. Abundant valleys are the ancient or the stream valley. Those have been filled with glaciers or unconsolidated sediments. These sediments are made of predominantly gravels, sands, silts, and clay, and these types of sediments can often store and transport large amount of groundwater and act as a local aquifer in terms of abundant or buried valleys. Then you have got plains. In the plains, you will have extensive high plains underlined by unconsolidated sediments, required sometimes of travel, gravel, sand beds, form important unconfined aquifers. These aquifers are recharged chiefly in the areas accessible to the downwards percolation of the water from precipitation and form occasional streams. Then you have got intermoded valleys. So intermoded valleys are underlain by tremendous volumes of unconsolidated rock materials derived by erosion of bordering mountains. So intermediate valleys contains unconsolidated alluvial deposits consisting mainly of sands and gravel layers that can supply large amount of water to the well. So you can see that through diagram we have been showing how this intermediate valleys will allow the water to get deposited into the underground water table. Then you have got limestone. Limestone is a sedimentary rock, consists mainly of calcium carbonates formed by the precipitation of CoCO3 from natural waters or by organic processes involving lime excreting animals. So limestone varies widely in density, porosity, and permeability on the degree of consolidation and development of permeable zone after deposition. Limely deposits are often have high and original porosities, but as they are changed into the sedimentary rock through compaction, they often become dense, hard rock with lower porosity. So limestone owes to its own unique hydrological property to the solubility of its major constituent CaCO3 in the water. Rainwater seeping down into the cracks of the limestone nearly carries CO2 carbon dioxide into the solution, and this gives the water a slight acidity and cause certain amount of CaCO3 to dissolve. And finally you will be finding the cracks and openings in many of the rock types, and the ultimate results will be limestone crevasses, but generally it becomes just a slightly enlarged solution openings that allows the water to infiltrate and flow through the rocks, and eventually even the densiest limestone can acquire enough porosity and permeability to be or become a good aquifer. So right now we are seeing the different rock types as a water bearing structures. Then you have got volcanic rocks. Volcanic rocks, especially, are lavas, make good aquifers. So they are important water bearing formations because of their distinctive systems of fractures and porous spaces, and they are widely occurred in variable conditions to form a good aquifer. So you can see that how the water, this is the topsoil, then you have got the limestone, then you have got volcanic rocks, and then you have got the water chamber. So this is a good water bearing structure, and these types of openings contributing to the permeability of basalt aquifers. Basalt lava, where it covers extensive area, often provides with both conducts for groundwater transmitter and reservoir for water storage. The vertical fractures in many basalt flows provides pathways for rainwater to penetrate, and the otherwise the dense lava rocks and the seep down to the porous zones between the flows. The porous interflow zones are effective long-range conducts for the groundwater. Then you have got sandstone. So sandstone is a cemented form of sands. Its porosity and yield has been reduced by the cementing material, and the best sandstone aquifer yields water through these joints. Otherwise, because of the cementing material, you'll be finding difficulty in penetration. And finally you have got igneous and metamorphic rock. It's in a solid form of impervious surface, and hence they are the poor aquifers. The rock names and the formations are not important, except they influence the rock hydrological properties. Volcanic rocks are also igneous rocks, but because they have got different hydrological property, they are considered as a separate identity. So you have got a crystalline rocks share two important attributes. They are the most important or always have a uniformly hard and dense rock, and they have got low porosities and permeability. And since aquifers depends on the porosity for the storage and permeability for the water transmission, the crystalline rocks generally will be poor aquifers. The groundwater reservoirs in these rocks appear mainly interconnected through three-dimensional fracture systems that stores, transmits the water through the rocks. And this is all for today. Hello, the recording is continuing.